Now latent heat. So see, we discussed this thing when the transition of the state takes place at that time. Both the states of the matter are at same temperature. So the heat exchanged, that is not increasing or decreasing the temperature, and therefore that particular heat is called latent heat, because if there is the exchange of heat, definitely the change in temperature takes place, but in this particular cases the temperature remains constant. So where this heat is gone, so that is utilized to change the state, and therefore it is known as latent heat. Now the definition of latent heat is given like this: the amount of heat transferred per unit mass of the substance during the change of state, that is called its latent heat. So we can write the latent heat L, that is Q by M, where Q, that is the amount of heat transferred during the change in state of m gram substance. So Q by M will give you the amount of heat transferred per unit mass, and that is the latent heat. Its unit, that is joule per kilogram. Clear? And when the transition between the states liquid and gas takes place, at that time the latent heat, that is called latent heat of vaporization. And during the transition of the states solid and liquid, the latent heat, that is called latent heat of fusion. And now let's try to understand this thing with the help of example of water, right? Suppose we take 1 kilogram of water, and suppose it is in the ice form, and its temperature, that is very much less compared to 0 degree Celsius. Now, if we supply the heat to that particular ice, which one is at temperature below 0 degree Celsius? So this position. So if we supply the heat to it, then that heat will be absorbed by ice. And now first the temperature of ice will increase. So now the temperature of ice increases up to 0 degrees Celsius. Now after that, the transition of the state starts. Ice will be melted. So after that, the amount of heat transferred to it will be absorbed by it and will be utilized to change the state. And here, see, just for information, it is given to you 333 kilojoule heat will be utilized per kilogram to melt the ice. Okay. Now, once the entire amount of ice is melted, then the water formed, that will be also at 0 degrees Celsius. Now, see, heat supply, that is constant. Keep this thing in your mind. Heat is constantly supplied to that one. Now the heat supplied to it is absorbed by it and utilized to raise the temperature. So now temperature is raised of this water up to 100 degrees Celsius. And now after 100 degrees Celsius, phase change will take place. So now water will be converted into steam. But now The temperature will remain constant at 100 degrees Celsius because the amount of heat absorbed by it that is utilized to change the state. And see here, 2256 kilojoule amount of heat will be utilized per kilogram to change the state of water to steam. Now, the steam that will be also at 100 degrees Celsius. But then after the heat absorbed by it that will be utilized to raise the temperature of the steam. So this is the process. Clear to all of you? So for water, we can say 333 kilojoule per kilogram. That is the latent heat of fusion. And 2256 kilojoule per kilogram. That is the latent heat of vaporization. Okay.